Hi, first of all, morjesta. I'm from Tampere, Force. I wanted to talk to you about Kotlin and Spring Boot. We've been working for about half a year with this now, and it was time for a little bit of a retro and like sharing what we learned here. And bit of a difficulty the last month. I haven't been working with Kotlin. I've just been working with Node and TypeScript. So some things are not routine yet, but yeah. We started with this because we had some issues, and these are actually slides from a presentation we gave at the client. We had a lot of XML data to handle, and that we had to stream that. And there were dependencies between XML messages. So we needed some kind of concurrency because it's a big load, and we still needed communication between like different handlers. And could you stop it though? And the team really liked typing, so we had no real typing in the current solution. So we started looking at some alternatives, and also because we actually got the chance to, like, from a really nice client, if you can find something better, I want to experiment and fail, let's do it together, but let's do it quickly. So we did some evaluation, Node.js and TypeScript, that would add some typing, but like it's a Goldilocks thing here, so that only solved part of our problem. You just get types at transpile time. And by the way, stop me if you have questions or opinions, or if I'm just dead wrong. I came to Helsinki because I heard you're an opinionated bunch. Yeah, so that was too soft. Then my personal favorite, we would go for Clojure, because that's the only language that makes sense. But that's dynamically typed, and the customer might want to have, as they say, commodity resources, aka developers on the cheap, and it's hard to find Clojure developers like for maintenance. So that was too hard. Then we talked about Java, and then like we came with this API factory builder, build, get factory, get API, and then we threw a null pointer exception and moved on. But we did like the idea of the JVM. So there was a lot of talk about Kotlin, and we decided to try that out. Just like our decision was based on a little proof of concept, and we found out it's statically typed, that's nice. It has type inference. It supports coroutines with use of JVM thread pools. That was something we didn't really understand. My father actually used this like a long time ago when he was in the 80s doing Scheme. Yay, modern technologies. And we found this really neat-looking DSL for XML parsing, the domain-specific language, which I will show a little example of in a bit. So we chose to go ahead with Kotlin and SpringBoot. And a little bit of background. What is Spring? Spring is an inversion of control container, and that basically means that it says there, don't call us, we'll call you. So you write code that sits inside a container. For example, there is a web server, and you just write code that the web server calls. Or, yeah, that's basically it. There's a command line version as well. But it's an application framework, so it has like possibilities for data access and object relational mapper. There is, now I have to look at me. Yeah, MVC, that's a possibility as well. Like you can generate server-side JSP, PHP-like things, which we skipped. And transaction handling, which is really important for us because we want to make sure it's client's data. We're talking about, for example, prices, products. So you want to make sure that if something consists out of many different data sources, that you in the end up with a consistent version of the truth. Spring 5, the latest release came, I think, this or last year. It is reactive, which means, like, I don't know if any of you know things like RxJS, or I think Bacon is the reactor version of it, or what. Anyway, all kind of like just observable pattern, like implementations, and we thought that would be a really cool way to go. But Spring itself is really heavy on XML configurations. You can easily write like tens of thousands of lines of configurations through your whole project. So there is something called Spring Boot, and that is the same thing, but then it has an embedded web server. And it allows you also to, it uses convention over configuration, sort of. So instead of like configure all these XMLs, you just call something the correct name or have the correct suffix or prefix, and either it will auto-generate your code or will react in the expected behavior. And one of the things, for example, a good example is a CRUD repository. If you just create an interface in Kotlin that is called reactive CRUD repository, and you have the correct libraries in the class path, it will understand that you're actually trying to access a database. It will look for a database configuration somewhere. It will automatically connect to that database and implement for you. If you annotate it with the correct class, it will provide you with a getter, a setter, a save method, a flush method, and streaming. So you can actually have all CRUD operations come out of the box. But yeah, the sort of, it still needs annotations and property files. So you get rid of the XML, and some of the properties. Then about Kotlin. Kotlin is, I would say, the best thing to come out of Russia after Michael, maybe? I don't know. Yeah, sucking up a bit. But yeah, it's developed by JetBrains. Some really smart people are there. Sorry? Okay. Yeah. Okay. It's made for developers by developers, so people got annoyed with, I guess, other JVM languages and decided to do it on themselves. It is a JVM language, but nowadays it also supports, it can compile to JavaScript, where you can have like, I don't know if you know closure script. It has the same kind of relation. You can have your domain classes in the middle, and your JVM part can use it, and your JavaScript can use it, so you don't have to duplicate code. Yeah, and nowadays it's a first-class citizen in Spring and in Android, which kind of gave us also the idea that this might be here to stay for a while at least. Let's talk about Kotlin a bit. Has any of you used Kotlin either, like as mobile developers or? Cool. Then you can correct me if it's wrong. Cool.
So there was for remote participants, 3 people in Helsinki raised their hands.
Yes, way too few. Anyway, the language it's loosely based on Java, C#, and then gone into its own direction. Some of the nice things that it takes from other languages and paradigms is, for at least these were the ones that we found nice, extension functions. Basically, you have like Ruby mix-ins or prototype in JavaScript, you can just add a method or a function to an existing class or prototype. This was something that was missing in JVM languages, apart from, of course, JRuby, which nobody uses. So here's a little example. Like, for example, there's a string class to represent strings. And because we hate z's, we can just add a function to it that removes all z's, and then it uses this, actually the contents of the instance of the class, and you can manipulate it in any way. It's really nice if you, if you have to do some custom data manipulation, for example, you can use existing classes and add these little helper functions to it. You can also scope it. It can be package private scoped. It can be like class internal scoped, so you don't have like what you sometimes had with Ruby, that you by accident, or with JavaScript, flat map anyone, or what was it? So you can avoid these kind of situations. It infers types, which is nice, because then you don't have to like declare your types everybody. I mean, everybody knows that something in double quotes is a string. Why do I have to tell it every time over and over again, as you do in Java? Though I think Java 11 might support inference already. And this maybe, if you don't do Java development, you're like, why would I care? This is a normal feature, but Java doesn't have any like concise ways to make a data class. If you want to store data in something, you're going to need a class, and you need to go and write your own hash code, comparison, all kind of functionality. And with Kotlin, you just end up with a one-liner, or maybe a few lines if you have more data, and it will provide you automatically with hash code and copying, comparing. It can destructure into single variables. And the language is null safe, and this is one of my favorite personally. I think Swift does the same thing. It has the same kind of paradigm. Like, everything by default is non-nullable, and if you want to make something nullable, you have to explicitly tell the compiler that this is not null. And if you use a good IDE, it will scream at you. You can force it with like double bang, so you can say like, okay, this thing, like I assume that this is not null.
There is a question. You said
Yeah,
that
go.
we can interrupt
Yes,
you.
please, by all means.
One comment about the null safety. It's null safe. It's null safe as long as you are not doing Java interop.
Yes, yes, that is true, and that I think that is the only valid reason for bang bang. That is, if you have some weird Java class that will provide you with a nullable type or nullable argument, and then you have to like live with it, and you don't want to use question marks everywhere, and you declare it once with bang bang, say, okay, I'm just going to trust this library that it's going to be not null. But yeah, that can make quite a mess of your code.
And also, if you have data classes with non-nullable values and some Java interop injects the stuff there, it might be null, even if the compiler says it shouldn't be, but it can be null on runtime.
Oh wow, we haven't gone that far. That sounds really bad, actually. But let's keep that in mind then. That is not in my negative things about Kotlin.
Yet.
But I'm going to chalk it up to Java sucks. So. Yeah, Elvis is back. So if you know the Elvis operator, you can it's like the sort of like the unary operator. You can say if something is null, then assign this value, and otherwise just use the value. It supports safe collections out of the box, which means that you can if for example a collection is empty, I think this could be a list or any other collection. Then you can say like or empty, and then it will make sure that if it's empty, it will just stop. You'll just get an empty object, or an empty collection, and otherwise it continues whatever you were mapping, reducing. And then we combine the two. Am I going too fast? Too slow? So we combine Spring Boot and Kotlin, and Kotlin has this nice thing, and notice I didn't put the slide up for that. You can write domain-specific languages really easily, or so I've been told. I tried, I didn't find it that easy, but then again. We use this, or we try to use this. I will come back to that, why we are not using it currently. If you come from JavaScript, this just looks like normal stuff in Happy or Express. But for Spring, this is a really nice way of functionally declaring your API or your router. I'm going to have to point a bit, but you could declare like your URL, and then you can nest stuff in your URL, and then you can just use it as there's a higher order function or functor for your post, your get, and you just put a function in there, and it will apply that function to the request that it receives. So I think it looks really pretty as far as routers go. Also, for example, filtering requests is easy in this case. If you do not have a valid token, it will just throw I think a 503 in the end. And another one, which was our main headache, was parsing XML, and this is this really cute little thing. I don't know, have you ever, show of hands, parsed XML? And who likes it? There we go. Just that we went from about 10 to 0 here. So especially if you have to stream XML, you end up with like an on this tag, and then you open it. You have to declare most likely global variables to start your tag and store stuff, and on close tag you actually save the value. This sort of does this for you, and it uses oh god, I don't remember one of the two, the streaming one of the XML parsing libraries. And you basically say, I have a data class, or a class in this case, and this field maps to, and then you say by JXML, which means use this DSL, and it maps to this field, and it is of that type, or this element and that type. And this will resolve it really nicely into a class, and you can nest classes, and this took so much headache away from us of these big, basically SAP-generated XML files. So we just map them straight away. It sort of documents itself as well. As you can see on the slides, like nobody would know that Mattner is actually a product ID unless you're a German SAP consultant. Then it makes sense. But yeah, this makes it much more readable for us. Then there's something about coroutines. Now, I'm not a computer scientist, and I try to avoid concurrency because concurrency just is really hard for me. And I read the book that actually was of the name Concurrency is Hard, I think. It is hard. Coroutines provide a lightweight alternative, and you kind of can think of them like threads that don't get interrupted from an external source, as far as I've understood the Wikipedia page. And the really nice, oh, I forgot the good man's name, a really nice guy I met in Estonia who explained coroutines very well. He's one of the writers of coroutines. Anyway, it's cooperative multitasking. That means that like the coroutine will yield if there is a gap. So it will process whatever it's processing. If it's idle itself or if it's blocked for some reason, then it will yield to another coroutine if they're in the same context. If you're interested, I don't think we have that much time, but I have a little code example just to show the difference between Java threads or native threads. Basically, we get an atomic integer, because we're in a thread, so we get an integer, and we just add all numbers from 1 to 1,000,000. And we do that, of course, concurrently, because we can. So if we use this with threads, I actually have never waited until the end, but this runs for a long time, because there's in the JVM there's a huge overhead for spinning up a thread. And first it spins up 1,000,000 threads, and then once the thread it starts adding. This takes a really long time. If we do the same thing, and I will put this on GitHub if you're interested or provide you the link. There's this thing with coroutines, which basically, instead of starting a thread, it launches, and launches a coroutine. If we call this one, there, done. 1,000,000 semi-simultaneous, of course, because they only yield when they block or are idle. So, really impressed with that. There is some more stuff to this, but yeah, come and chat with me after this, and I can point you at least to the correct documentation. So to come back to what worked, like Kotlin is really fun and easy. You feel that a developer made it. Like if I would make a language, I would probably go along the same route. It's like mainly functional, but it still has the object-oriented that when I want it. Encapsulation is really easy, but not so hard that I have to expose stuff for public just because I want to write a unit test. It feels nice. And these existing DSLs, they're really good. I'd really love to spend some time, and I probably will burn some EBIT on that, writing my own DSL just to see how that feels. Debugging JVM memory, because I haven't done much Node before I came to Futurice, and then I was in a Node project, and I had a memory leak. The V8 is great, but when you have a memory leak, you get a list of objects and a list of closures. Okay, so I have too many objects. What kind of objects? I don't know, 1,000,000. Yeah, but what kind of objects? Well, 1,000,000. So the JVM is a bit nicer in that like you can profile it really easily. It's like this type of object came from that. You have clear stack traces everywhere. Of course, if you use closure, you don't even need stack traces. But coroutines are easier to handle than threads. The repository pattern in SpringBoot really makes saving data easy. It works for Elasticsearch, for Mongo. It can be reactive, so you put data in your database and it just streams. Spring Cloud, because we actually use stuff on Amazon, we get SQS messages and we get files from S3. It is like working with your local file system. It's just nicely wrapped. And Spring had a nice method of dependency injection. You annotate, you say auto-wired, and it will automatically instantiate a class of the interface you specify. That is really great. But, yeah, we are a bit divided on this in our team, but I think our consensus is that Spring wasn't the thing for us. But we still have to have a good retro about that and see what we want to use and what not. 20-second startup time for a high availability API is not what you want. If you, for example, work with something like Heroku, which we do, and Heroku starts cycling, you might actually end with actual downtime. And that is like maybe a few seconds, but if you have a web store or if you were operating an energy grid, which I know from experience you do not want that second of downtime. High memory usage, Spring Boot just like starts up nothing 300K right there. So you need to get like a bit more of an expensive VM for that. It has some funky undocumented behavior. For example, it doesn't work with Postgres out of the box. You have to find some undocumented property somewhere from a Stack Overflow, like, you know, it's like Hitchhiker's Guide in the basement, behind a door, or cupboard, anything. And the fancy router that I just showed, it is unable to generate Swagger dogs. So we went back to the unfancy one that actually can automatically generate. Because we have statically typed stuff, why do I want to manually like tell what kind of types I have? No arg default constructors, there is something. Basically, when you define this data class, Kotlin automatically generates like a class behind it. And it, of course, because you say that some properties are mandatory because they're not nullable, it will not generate a default constructor, like a constructor with no arguments. Spring, however, if it wants to save something to the database, it first creates a no argument constructor, like it creates an empty object and then it sets all the values. And yeah, that took a while to find out that there is actually Kotlin comes with a special package. If you put it in your class path, then it will solve this. But yeah, that was a bit of a challenge for us. Also JPA, which is the Java persistence API, basically to get this ORM, saving your stuff in the database, it needs a lot of tuning. Like simply joining two tables together and streaming data out of it, like requires more annotations than I would like. And last but not least, I mentioned dependency injection is great. However, if you can, and that is the same for Java and the same for .NET if you use Entity Framework, you can easily inject stuff. It is so easy that at the point where if you don't do TDD, you will end up with a really clean looking piece of code with a couple of annotations, but once you write your test, you end up mocking half your system to only like to set your test up and you haven't even done anything. So yeah, it requires quite a lot of self-discipline to use this. That's it. I felt like I rambled, but I'm on time.
Perfect. Thank you very much. Okay, let's start with the remote. Do we have any remote questions, friends, from outside? We are going to count to a 5, 4, 3, 2, 1, and Mike goes to Helsinki. Questions from here? No questions.
Thank you, Michael. So it sounds like there's a lot of magic going on, I think mostly in Spring. Do you have any tips how to cope with that?
I find meditation helps. But actually reading a lot of the specifications helps. Like a couple of times we had to actually dig into the source code of Spring Boot, which is uncomfortable. But if you use a framework, of course, you should read the specification and know what you're using. And I know the easier the framework, the less you feel obliged to actually read. At least I personally, I'm not projecting on you, of course, but like personally, like for example, Happy, I don't know half of how the plugin system works, but I just assume it works. And I think it's here the same, but the abstractions leak through quite more often than in a Happy Express setting, I find. But yeah, read the specs a lot.
What if the specs are bad?
Do you intend to stick with Spring, or do you plan to switch to something else in the future?
We don't know yet, actually. We feel like we're going to stick with Kotlin, but about the Spring part, we still need to have a good retro, like where we actually sit down and have some time to go through some options. Yeah, I don't know. I have a feeling that Spring offers a lot, like the Spring Cloud, all those things, but they are not Spring Boot, so they are not configuration over convention, or convention over configuration, sorry. So these are the property files, XML things. So, yeah. But
Anybody else?
anyone?
I have I saw somebody remote with the microphone in the hand. Is it still a thing, or?
Or is Thomas Forst just going for karaoke?
Okay. Okay.
No questions.
Wow. So are you using it with the JetBrains JDK?
Yes.
So and they
Or
were
no, wait. You mean the JDK?
yeah.
No, we're using
So no special
OpenJDK.
source from JetBrains.
no,
Yeah.
only
okay.
the IDE.
Yeah, only the IntelliJ.
Yeah.
Okay. Do you know if there are any discussions like from their side? Is there going to be any benefit moving from like Java 8 to like 9, 10, and 11, or?
Not that I'm aware of, which
Okay.
doesn't mean that there is not.
Okay.
I kind of stopped following the Java scene after
Okay.
9. The modules really turned me off
Okay.
on Java.
Hey friends, if there are no more questions or suggestions, or then the very last one, would you do it again?
Yes, yes.
So
definitely.
even favor this versus closure. Oh, the hard one.
Within the constraints, yes.
Okay.
Yes.
But probably not with the Spring Boot.
No.
Okay.
No.
Got it. Hey, thanks a lot. Let's have another round.
Thank you.